Hello everyone, this is Saurabh from Edureka. Welcome everyone to today's session on what is deep learning. We'll understand how deep learning emerged. That is, what were the limitations of the previous technologies that led to the evolution of deep learning. So let us have a look at the agenda for today. First, we'll understand what is artificial intelligence and what exactly is machine learning. Then we'll look at various limitations of machine learning and how deep learning solves or overcame those limitations. After that, we'll understand what exactly is deep learning and we'll also look at various applications of deep learning. So I hope you all are clear with the agenda. So let us move forward and understand artificial intelligence. But the first thing that we need to focus on is why artificial intelligence? Why do we need artificial intelligence? Now let us understand this with an example. So nowadays, if you have noticed, if your car exceeds the speed limit, so you'll get a letter or basically a challan at your home. How do you think that happens? Do you think that there's a person who is sitting in a chair and actually noting down all the number plates that crosses the speed limit? Well, that is not possible because there might be millions of cars that pass through that road. And at once there might be many cars that will be passing through that road. So for a human being to actually do this task is next to impossible. Now let us see another approach to this particular problem. So what we can do, we can actually make use of cameras that will click the picture of the car that exceeds the speed limit, and then we can convert that picture into a text. For example, we have a UKPLATE. So in this way, the risk of human error has been reduced, and at the same time, machines, they never get tired. So because of that, you can capture all the images of cars that actually crosses the speed limit. Similarly, you can think of many other examples as well. It is used in order to recognize a sign, that is in banks if you want to authenticate whether that person is the bank customer or not. Apart from that, it is even used for self-driving cars as well. So in US, around 30,000 people die every year because of road accidents. So that can be completely removed if we use the self-driving cars, which is based on the concept of artificial intelligence. And let me tell you guys, you might find it very fascinating that people in MIT are using artificial intelligence in order to predict the future. So you can imagine why we need artificial intelligence. It is even used in places where humans can't reach. For example, deep oceans or navigation in Mars. So in those places, we need machines which are smart enough to carry our tasks. So this is why we need artificial intelligence. Let us move forward and understand what exactly is artificial intelligence. Now, artificial intelligence, I know the word sounds pretty complex and there are a lot of Hollywood movies that are based on artificial intelligence. If you have seen Terminator or Matrix, so all these movies are based on artificial intelligence, but you don't need to worry about it because till now we haven't reached that level as they have shown in movies like Terminator. But yeah, the concept is pretty similar. So basically, we want systems and softwares in such a way that they can imitate the human behavior. Now, what happens in artificial intelligence? Artificial intelligence is accomplished by studying how human brain thinks and how human brain learns, decide and work while trying to solve a problem. And then we use the outcome of this study as the basis of development of intelligent software and systems. So our major goal is to have systems or softwares that can imitate the human behavior. The way they think, the way they decide, the way they solve a problem. So in that similar fashion, we want our machines to do that. So this is basically artificial intelligence in a nutshell. Let us move forward and look at various applications of artificial intelligence. So this slide basically talks about the application of artificial intelligence. Now I've listed only three of them, but there are millions of applications. For example, it is used in speech recognition. So whenever you search something on Google, so you can just tell Google and it'll search it for you. Similarly, it is used for understanding natural language as well as for image recognition as well. And there are many other applications in which artificial intelligence finds its use. For example, it can be used in self-driving cars, it can be used in Siri for recommending some products, and even when you go to websites like YouTube or Pandora, YouTube knows which video you want to next. Pandora knows which song you want to listen to. How do you think this happens? It happens all because of artificial intelligence. So all of these are a few examples of artificial intelligence, but nowadays it is used almost everywhere, guys. Trust me on that. Now let us move forward and understand how to achieve artificial intelligence. Now, in order to achieve artificial intelligence, there were a few technologies that came. First came machine learning. Now, there were certain limitations of machine learning. In order to overcome those limitations came deep learning. Now, let me tell you guys, the concept of artificial intelligence is not new. It was first coined in 1956, but it was just a theoretical concept. Then in 80s and 90s, we were talking about neural networks. But since we didn't have enough computational power, so we couldn't utilize it properly. But in late 90s and 2000s, we started using neural networks for machine learning. Then in 2006, the term deep learning was coined for the first time that overcame the limitations of machine learning. And from 2010, deep learning was used commercially as well. So this was just a small history about artificial intelligence, machine learning, and deep learning. Now, in order to understand this deep learning, we need to first look at machine learning and what were the various limitations of machine learning that led to the evolution of deep learning. How does that sound, guys? All right, fine. So I can see a lot of people agreeing to me. All right, cool. So we'll move forward and understand what exactly is machine learning. Now, what is machine learning? So machine learning is nothing but a type of artificial intelligence, or you can say a subset of artificial intelligence. And it provides computers with the ability to learn without being explicitly programmed. So you don't need to hard code your machine for that. Let us understand this with an example. So we have a problem statement in which whenever you give a certain input, we need to determine the species of the flower. And what is that input? That input will be sepal length, sepal width, petal length, and petal width. So whenever we get these four parameters or these four variables, our machine should be able to predict what sort of a flower it is. Now, how do you think that will happen? First, what we need to do, we need to train our machine on the basis of the data that we have. So in this data, we have sepal length, sepal width, petal length, and petal width, and we have species. So our machine will learn from this data. It will determine what should be the length and width of the sepal and petal in order to classify it as setosa or versicolor or other species of flowers as well. Now what happens next? So you have trained your data. So you have trained your machine from the data set. Then what happens, whenever you give a new input to this particular machine, it will predict the species of the flower. So this is how machine learning works. It is nothing but machine learning in a nutshell. So basically, I'll just revise it once more. So you have a data set. So you split that data into training and testing data. So what happens with the help of training data, you train your particular machine. And after that, you test it in order to determine the accuracy. And once it is done, whenever you give the new input, it'll predict the outcome or the desired outcome. So this is how machine learning works, guys. Let us move forward and understand various types of machine learning. So the first type is called supervised learning. Now in supervised learning, what happens, you have input variables X and an output variable Y. And you can use an algorithm to learn mapping function from the input to the output. Now let me simplify it for you. So what happens in supervised learning, the data that you have already contain the classification. Now let me talk about the previous example itself. So from our data set, we knew that if we have this width, this length of our sepal and petal, so that will be the species of flower. So the classifications are already defined. So that will be under supervised learning. Now let me tell you how it actually works. So you have data, you divide that data into training data as well as test data. So on the basis of this training data, you train your machine, and after that you create a model. So as you can see that this phase is called training phase, and after that you create a model. Now in order to check this model to get the accuracy, you have test data. So you'll pass that test data and you'll see the accuracy. That is nothing but the actual output minus the output that is present in the test data. So with that, you can get the accuracy. So this is all about supervised learning. So we'll move forward and understand unsupervised learning. Now in unsupervised learning, unlike supervised learning, you don't have any predefined classes. So what happens, you have data. So on the basis of that data, you try to create your own class. You try to make sure that whatever class you create has high intra-class similarities and have low inter-class similarities. That means if I've created two classes like this, class 1 and class 2, so the elements of this particular class should have high similarity, but at the same time, it should have low similarity with the elements of class 2. So you can think of examples as well of unsupervised learning. For example, if I have a data about my customers, so if I have a website and there are millions of visitors on my website, and I want to make sure that I group people on various criteria. For example, I can group people on the basis of willingness to purchase a product that is there on my website, or where they are coming from, what is the source, all those things. So I want to group my customers, and I want to make sure that I have certain high priority customers and I have low priority customers and I have medium priority customers. So with the help of unsupervised learning, I can actually do that. I can make certain classes of people on whom I should focus more on as compared to the other class. So this was just an example, guys. You can use it in various other fields as well. So in marketing, this is how you can use unsupervised learning. Alright, so this brings us to our next type of machine learning, which is called reinforcement learning. Now this is reinforcement learning, guys. Now what happens in reinforcement learning? The machine learns by interacting with space or an environment. So it learns with its experience, with its past experience, and also by new choice exploration. Now I'll take the analogy of dogs. So if you have any dog or a pet at your home, so if you have trained your dog in order to get the newspaper, and if it gets it, then you reward it with some chocolate or things that the dog likes, right? So the dog will know whatever he has done, he's actually rewarded for that. So it'll continue doing that. But apart from that, if he does something else, if instead of the newspaper, he brings something else. So what you'll do, you might even punish it. So because of that, the dog will come to know that it has to get a newspaper every morning. Now, the same example is there in front of your screen. So you have this machine. So it has two choices, either to touch the fire or touch the water. Now, first, what it does, it goes on and touch the fire. So because of that, it gets some burning sensation. Now it has only other option, that is to touch the water. So when it touches the water, it gets some reward. So because of that, it'll understand that it does not have to touch fire ever again. Now there's a diagram that is there in front of your screen. So what happens is you have an agent, all right, that agent performs some action. And on the basis of that action, it'll be exposed to some sort of an environment. Now if that action is correct, then it'll be rewarded with that. But if it is not, then it'll change its choice and it'll again perform some action. So this process will keep on repeating. So this is how reinforcement learning works. So let us move forward and understand when we have machine learning, why do we need deep learning? That is, we'll look at various limitations of machine learning. Now the first limitation is high dimensionality of the data. Now the data that is now generated is huge in size. So we have a very large number of inputs and outputs. So due to that, machine learning algorithms fail. So they cannot deal with high dimensionality of data, or you can say data with large number of inputs and outputs. Now there's another problem as well in which it is unable to solve the crucial AI problems, which can be natural language processing, image recognition, and things like that. Now one of the biggest challenges with machine learning models is feature extraction. Now let me tell you what are features. So in statistics, we consider features as variables, but when we talk about artificial intelligence, these variables are nothing but the features. Now, what happens because of that? The complex problems such as object recognition or handwriting recognition becomes a huge challenge for machine learning algorithms to solve. Now, let me give you an example of this feature extraction. Suppose if you want to predict that whether there will be a match today or not. So it depends on various features. It depends on whether the weather is sunny, whether it is windy, all those things. So we have provided all those features in our data set. But we have forgot one particular feature, that is humidity. And now our machine learning models are not that efficient that they will automatically generate that particular feature. So this is one huge problem, or you can say limitation with machine learning. Now, obviously we have limitation and it won't be fair that if I don't give you the solution to this particular problem. So we'll move forward and understand how deep learning solves these kind of problems. Now, as you can see that the first line on your slide, which says that deep learning models are capable to focus on the right features by themselves, requiring little guidance from the programmer. So with the help of little guidance, what these deep learning models can do, they can generate their features on which the outcome will depend on. And at the same time, it also solves the dimensionality problem as well. If you have a very large number of inputs and outputs, you can make use of a deep learning algorithm. Now, what exactly is deep learning? Again, since we know that it has been evolved by machine learning, and machine learning is nothing but a subset of artificial intelligence, and the idea behind artificial intelligence is to imitate the human behavior. The same idea is for the deep learning as well, is to build learning algorithms that can mimic brain. Now let us move forward and understand deep learning, what exactly it is. Now the deep learning is implemented with the help of neural networks, and the idea or the motivation behind neural networks are nothing but neurons. What are neurons? These are nothing but your brain cells. Now here's a diagram of neuron. So we have dendrites here which are used to provide input to our neuron. As you can see, we have multiple dendrites here, so these many inputs will be provided to our neuron. Now this is called cell body, and inside the cell body we have a nucleus which performs some function. After that, that output will travel through axon and it will go towards the axon terminals, and then this neuron will fire this output towards the next neuron. Now the studies tell us that the next neuron, now, or you can say the two neurons are never connected to each other. There's a gap between them. So that is called a synapse. So this is how basically a neuron works like. And on the right hand side of your slide, you can see an artificial neuron. Now let me explain you that. So over here, similar to neurons, we have multiple inputs. Now these inputs will be provided to a processing element like our cell body. And over here in the processing element, what will happen? Summation of your inputs and weights. Now, when it moves on, then what will happen? This input will be multiplied with our weights. So in the beginning what happens, these weights are randomly assigned. So what will happen if I take the example of x1, so x1 multiplied by w1 will go towards the processing element. Similarly x2 and w2 will go towards the processing element, and similarly the other inputs as well. And then summation will happen, which will generate a function of s, that is f of s. After that comes the concept of activation function. Now what is activation function? It is nothing but in order to provide a threshold. So if your output is above the threshold, then only this neuron will fire, otherwise it won't fire. So you can use a step function as an activation function, or you can even use a sigmoid function as your activation function. So this is how an artificial neuron looks like. So a network will be multiple neurons which are connected to each other will form an artificial neural network. And this activation function can be a sigmoid function or a step function. That totally depends on your requirement. Now once it exceeds the threshold, it will fire. After that, what will happen? It will check the output. Now if this output is not equal to the desired output, so these are the actual outputs and we know the real outputs. So we'll compare both of that and we'll find the difference between the actual output and the desired output. On the basis of that difference, we are again going to update our weights. And this process will keep on repeating until we get the desired output as our actual output. Now this process of updating weight is nothing but your back propagation method. So this is neural networks in a nutshell. Now let me tell you guys, this is just an introductory session to deep learning, just to explain you how it actually emerged. What are the reasons it came into existence, and a little bit introduction about how it actually works. So we'll move forward and understand what are deep networks. So basically deep learning is implemented by the help of deep networks, and deep networks are nothing but neural networks with multiple hidden layers. Now what are hidden layers? Let me explain you that. So you have inputs that comes here. This will be your input layer. After that, some process happens and it'll go to the next node, or you can say to the hidden layer nodes. So this is nothing but your hidden layer 1. So every node is interconnected, if you can notice. After that, you have one more hidden layer where some function will happen. And as you can see that again, these nodes are interconnected to each other. After this hidden layer 2 comes the output layer. And this output layer, again, we are going to check the output, whether it is equal to the desired output or not. If it is not, we are again going to update the weights. So this is how a deep network looks like. Now there can be multiple hidden layers. There can be hundreds of hidden layers as well. But when we talk about machine learning, that was not the case. We were not able to process multiple hidden layers when we talk about machine learning. So because of deep learning, we have multiple hidden layers at once. Now let us understand this with an example. So we'll take an image which has 4 pixels. So if you can notice, we have 4 pixels here, among which the top 2 pixels are bright, that is, they're black in color, whereas the bottom 2 pixels are white. Now what happens? We'll divide these pixels and we'll send these pixels to each and every node. So for that we need 4 nodes. So this particular pixel will go to this node, it will go to this node, this pixel will go to this node, and finally this pixel will go to this particular node that I'm highlighting with my cursor. Now what happens? We provide them random weights. So these white lines actually represent the positive weights and these black lines represents the negative weights. Now this particular brightness, when we display high brightness, we'll consider it as negative. Now what happens? When you see the next output or the next hidden layer, it will be provided with the input with this particular layer. So this will provide an input with positive weight to this particular node, and the second input will come from this particular node. Since both of them are positive, so we'll get this kind of a node. Similarly, this node as well. Now when I talk about these two nodes, the first node over here, so this is getting input from this node as well as from this node. Now over here we have a negative weight. So because of that, the value will be negative, and we have represented that with black color. Similarly, over here as well, we are getting one input from here which has a negative weight, and we another input from here which again has a negative weight. So accordingly, we get again a negative value here. So these two becomes black in color. Now if we notice, what will happen next, we'll provide one input here which will be negative and a positive weight, which will be again negative, and this will be also negative and a positive weight. So that will again come out to be negative. So that is why we have got this kind of a structure. If you notice, this is nothing but the inverse of this particular image. When I talk about this node over here, we are getting the negative value with a positive weight, which is negative, and a negative value with a negative weight, which is positive. So we are getting something which is positive here. Now obviously I want this particular image to get inverse. I want these black strips to come up. So what I'll do, I'll actually calculate the inverse by providing a negative weight like this. So over here I've provided a negative weight, it will come up. So when I provide a positive weight, so it'll stay wherever it is. After that, it'll detect, and the output you can see will be a horizontal image, not a solid, not a vertical, not a diagonal, but a horizontal. And after that, we are going to calculate the difference between the actual output and the desired output, and we are going to update the weights accordingly. Now, this is just an example, guys. So guys, this is one example of deep learning where what happens, we have images here. We provide these raw data to the first layer, to the input layer. Then what happens, these input layers will determine the patterns of local contrast, or it will fixate those patterns of local contrast, which means that it will differentiate on the basis of colors and luminosity and all those things. So it will differentiate those things. And after that, in the following layer, what will happen, it will determine the face features. It will fixate those face features. So it will form nose, eyes, ears, all those things. Then what will happen, it will accumulate those correct features for the correct face, or you can say that it will fixate those features on the correct face template. So it will actually determine the faces here, as you can see it over here. And then it will be sent to the output layer. Now, basically, you can add more hidden layers to solve more complex problems. For example, if I want to find out a particular kind of face, for example, a face which has large eyes or which has light complexion. So I can do that by adding more hidden layers. And I can increase the complexity also at the same time if I want to find which image contains a dog. So for that also I can have one more hidden layer. So as and when hidden layer increases, we are able to solve more and more complex problem. So this is just a general overview of how a deep network looks like. So we have first patterns of local contrast in the first layer. Then what happens, we fixate these patterns of local contrast in order to form the face features such as eyes, nose, ears, etc. And then we accumulate these features for the correct face, and then we determine the image. So this is how a deep learning network, or you can say deep network, looks like. So here are a few applications of deep learning. It can be used in self-driving cars. So you must have heard about self-driving cars. So what happens, it'll capture the images around it. It'll process that huge amount of data, and then it'll decide what action should it take. Should it take left, right? Should it stop? So accordingly, it'll decide what action should it take. And that will reduce the amount of accidents that happens every year. Then when we talk about voice control assistants, I'm pretty sure you must have heard about Siri. All the iPhone users know about Siri, right? So you can tell Siri whatever you want to do. It'll search it for you and display for you. Then when we talk about automatic image caption generation, so what happens in this, whatever image that you upload, the algorithm is in such a way that it will generate the caption accordingly. So for example, if you have, say, blue colored eyes, so it will display a blue colored eye caption at the bottom of the image. Now, when I talk about automatic machine translation, so we can convert English language into Spanish, similarly Spanish to French. So basically, automatic machine translation, you can convert one language to another language with the help of deep learning. And these are just few examples, guys. There are many, many other examples of deep learning. It can be used in game playing. It can be used in many other things. And let me tell you one very fascinating thing that I've told you in the beginning as well. With the help of deep learning, MIT is trying to predict future. So yeah, I know it is growing exponentially right now, guys. So this is it for today's session on what exactly is deep learning. We'll move forward and I'll just give you a quick summary of what all things we have discussed. So first we saw why we need artificial intelligence. So basically things that humans cannot perform, we want a machine to learn and do those tasks for us. Then we understood what exactly is artificial intelligence and what are the various subsets of artificial intelligence like machine learning, deep learning, etc. So we first focused on machine learning. We saw what exactly it is. We saw various types of machine learning, namely supervised, unsupervised, and reinforcement. Then we focused on various limitations of machine learning that led to the evolution of deep learning. Then we saw a use case in which we saw how to recognize an image using deep networks. So this was it for today's session. Thank you and have a great day.